Hello, Geometry Advanced students. So in this particular lesson, it's titled Trigonometric Ratios. So we've already reviewed sine, cosine, and tangent, those three trig ratios, and which pairs of sides as a ratio we use for each specific trig ratio. So remember, for some of you, if we remember SOHCAHTOA, so again, SOHCAHTOA will help you to identify which trig ratio you need to be using. So S stands for sine, and sine is the ratio of the opposite side to the hypotenuse side. C stands for cosine, and cosine is the ratio of the adjacent side to the hypotenuse. And then finally, T stands for tangent. Tangent is the ratio of the opposite side to the adjacent. So again, we're going to use sine, cosine, and tangent to help us solve right triangles. So in the examples we're going to do today, we're either going to find a missing side or a missing angle, depending on our problem. So let's take a look at the first one. So it says find angle A. So this is angle A in the picture. So we need to identify the sides that we know so we can pick the correct trig ratio. So with respect to angle A, the side of 4 here is the opposite because it's across from it, and the side of 3 is the adjacent side. So if we think sine, cosine, or tangent, which of the three uses the opposite and adjacent? So O and A, I'm going to pick T for tangent. So we're going to say the tangent of angle A equals the opposite, which is 4, to the adjacent, which is 3. So if we're trying to find the angle, we're going to take the inverse tangent of both sides. So it looks like this on your calculator. Okay, so if I grab my calculator, I'm going to hit second and tangent. So notice it looks like that on my screen, inverse tangent. And in parentheses, I'm going to type in 4 divided by 3 because it's, again, 4/3. And if I hit enter, that means my angle, and let's round to the nearest degree. So I would say this is about 53 degrees. So again, this is an example where we had to find an angle. Actually, all of them on the front side of the notes here, we're finding an angle. Okay, so if I look at the second one, this time it says find angle B. So with respect to angle B, across from it, the side of 2 is the opposite, and the side that's a square root of 13 is the hypotenuse because it's across from the right angle. So again, if I pause and think, which trig ratio uses opposite and hypotenuse? So if I look at the top here, O and H, that's S for sine. So I'm going to say the sine of angle B, again, is opposite over hypotenuse. So the opposite is 2. The hypotenuse is the square root of 3. So if I'm trying to find the angle, I'm going to take, in this case, since I'm dealing with sine, I'm going to do the inverse sine of both sides. So I'm looking at the inverse sine of 2 over the square root of 13. So I'm going to grab my calculator. So I'm going to hit second sine to get it to show up on my screen. And then I'm going to do 2 divided by the square root of 13. And that gives me, again, if I round to the nearest degree, if it's 33.69, this is going to round to about 34 degrees. Okay. And then finally, if I look at the last one here, again, it says find angle A. This is angle A in the picture. So with respect to angle A, if this is the right angle, that means 10 is the hypotenuse and 4 is the adjacent. So if I look at the top of my paper here, again, if I'm doing adjacent and hypotenuse, I need to be looking at cosine. So I'm going to say the cosine of angle A. And again, cosine is adjacent over hypotenuse, so it'd be 4 over 10, or if you'd rather write that as 2/5, that is fine. So again, if I'm trying to find the angle, I'm going to do the inverse cosine of both sides. So again, I'm going to take my calculator, and I'm going to hit second cosine, again, to get that to show up. And in parentheses, I'm going to type in 4/10, or if you'd rather type in 2/5, that's fine. And again, if I'm going to round the angle to the nearest degree, if it says 66.4, we're going to keep that as 66 degrees. So those are 3 examples where you're trying to find a missing angle, again, using your trig ratios. If I continue to the back side of the worksheet, instead of finding angles, now we're going to find a missing side. So if I look at this first picture, I know it's kind of hard to read, but this angle is 25 degrees. Angle C is my right angle. You can see this side is X and this side is 30. So again, the first thing I would recommend doing is to find which trig ratio you need to be using. So again, you want to focus on an acute angle in the picture. So we know this is 25 degrees. So with respect to this, the X is the opposite, and the 30, since it's across from the right angle, is the hypotenuse. So again, if I write it on this side as well, SOHCAHTOA. Okay, which trig ratio uses O and H, opposite and hypotenuse? So here's O and H. I'm looking for sine. So I'm going to write it as the sine, and my angle here is 25 degrees. That equals the opposite, which is X, over the hypotenuse, which is 30. So again, what we're going to do is solve for X. So I'm going to take my calculator. Okay, so the sine of 25 degrees, and we're going to keep 4 places after the decimal. So this is going to be 0.4226, again, equals X over 30. So again, to solve for X, one way that works well for a lot of people is to put the decimal over 1, because anytime you put the decimal over 1, it's itself, and do cross products. So 1 times X is X, and then I'm going to take 30 times 0.4226, and I get 12.678. So let's just say on this one, let's round to the nearest 10th. That sounds like a good idea. So I'm going to round this to 12.7. So again, this time we're using our trig ratios to find a missing side. If I look at the problem on the right, so what I would focus on is maybe this top highlighted triangle here. Okay, so again, we have our right angle. This angle here is 65 if it's hard to read. Now, this is going to be a rectangle. So if this side is 65, or it's not 65, sorry, is 52, then this side over here across from it is also 52. And I want to find this side here of X. So again, with respect to my acute angle, the 52 is the adjacent side, and the X, since it's across from the right angle, is your hypotenuse. So if I'm looking at SOHCAHTOA, you know, which trig ratio uses adjacent and hypotenuse? Hopefully you're going to say it's AH here. We got the C. C is for cosine. So we're going to write it as the cosine, and my angle here is, not 52, sorry, 63 degrees. And again, that equals the adjacent, which is 52, over the hypotenuse, which is X. So again, I'm going to take my calculator. The cosine of 63 is 0.453, okay, so that's going to be 0.4540. Again, that equals 52 over X. So if I'm going to solve this for X, I'm going to put the decimal over 1 and do cross products. So we're going to have 0.4540X equal to 52. So to finish, I'm going to take my calculator and do 52 divided by 0.4540. And if I'm going to round to the nearest 10th, it would be 114.5. So again, we're using our trig ratios to find a missing angle, or in these cases, a missing side. Okay, in my last one of this type, again, we are finding X. So what I would recommend doing is focusing on this highlighted right triangle here. So this angle here is 38. This is X. And since it's an isosceles trapezoid, you have really faint tick marks here and here. So if this side is 25, so is this one. So with respect to this angle, okay, the x is the opposite and the 25 is the hypotenuse. So if I'm going back to my trig ratios, you know, which one uses O and H, opposite and hypotenuse, that would be S for sine. So in this one, I'm going to say the sine, again, of my angle is 38 degrees. That equals the opposite, which is x, over the hypotenuse, which is 25. So again, I'm going to take my calculator. I'm going to type in the sine of, it was 38 degrees. So if I keep 4 places after the decimal, it's going to be 0.6157. 0.6157, again, equals x over 25. So again, to solve for x, I would recommend putting your decimal over 1 and doing cross products. So 1 times x is x, and then if I take my calculator and type in 25 times 0.6157, and I round to the nearest tenth, I'm going to say that's about 15.4. So again, those are 3 examples where we had to find the missing side. Okay, so let's take a look at one more problem. This last one, it says we're given a cube with a side length of 6. So again, that means all the dimensions of my cube are 6. We want to find angle FHB. So FHB is this one here. Okay. So again, in the bottom of this cube, we have a 45, 45, 90. So if it goes 6, 6, this is 6 root 2. And again, all the dimensions of the cube, length, width, height, they're all 6. So that means the segment BF here is 6 as well. So if we want to find this angle, so again, if you're not sure here, this is the highlighted right triangle here we have. So again, the 6 over here would be the opposite, and the 6 root 2 would be the adjacent. So again, if I go back to SOHCAHTOA and think which trig ratio uses opposite and adjacent, it's going to be T for tangent. So we're going to say the tangent, and I don't know what the degree is. So the tangent of angle FHB, again, equals the opposite, which is 6, over the adjacent, which is 6 root 2. So to find this angle, FHB, we're going to do the inverse tangent of both sides. So again, we're going to do the inverse tangent of 6 divided by 6 root 2. So again, I'm going to take my calculator, I'm going to hit second and tangent to get tangent to the -1 to show up on the screen. And in parentheses, I'm going to type in 6 divided by 6 square roots of 2. And to the nearest degree, it looks like we're going to have about 35 degrees. Okay, so again, those are some examples to help you find a missing side or a missing angle. So basically, you are solving the right triangle. And as always, if you have any questions, please let me know.